Good morning, boys and girls. Okay, we have completed the chapter 7. Now look at the exercises. Okay, so we'll do the question answers later. First, we'll do the exercises. And our first exercise is pick the correct one. So look here. Okay, now, first one. The direction of freely suspended magnet. Okay, now if you suspend a magnet, uh, that means if you tie a bar magnet from the center or the middle of it so that it balances and hold it, uh, okay, then it moves and it will stop in a direction of north and south. Okay, so the ends always face, one end faces north and one end south. So this is the correct option here. Now, force between two magnetic poles. This is a magnet here, a bar magnet. Now this is the distance between the poles, that is R, and K is the strength, the constant. That means it has a fixed strength. So now how to calculate the force between the two poles? So that is, because K is constant, it remains the same. But it is the square of the inversely proportional to the square of the distance between the poles. Okay, so this formula gives you the force between the two poles of a magnet. Okay, so this is not in your syllabus actually. So just do it and will not go into detail. Okay, because I don't know how this question is given here, but still we'll do it. Okay. Okay, this is the correct option. Now, strength of a magnetic field of an electromagnet. So it depends upon what factors. So we have done it earlier in our chapter. Okay, you can watch the video again, find the answer, or look into your books. It is given in your book also. You can see here. Okay, where it is. Okay, here it is. You can see strength of electric current. So first factor is how much electric current is given. More electric current means more strength. Then number of turns of wire. So more the number of turns, more is the strength. Now material of the core. So it can be iron or nickel. So it depends upon the material also. So these three are the factors. Now look here. First one is strength of electric current, it is there. Number of turns, it is there. And third is also material of wires also. So all factors are there. Here this option is not given, none is given, so you cut it and write all of these. Okay. Now the fourth one, electromagnetism means. So electromagnetism is when a magnet is produced or magnetic force is produced using electric current. So now we'll find the correct option. Generation of electric field when application of magnet. So this is not the electromagnet because we are generating electric field here. We need to generate magnetic field. So here generation of magnetic field with application of current. So this is our correct option. Okay. So mark it here. Now cell is an arrangement which, so what does the cell do? It changes chemical energy to electrical energy. Okay. So the first one is the correct option. So what does a cell do? Changing chemical energy to electrical energy. And okay. Path of electrons in a conductor is, so path of electrons in a conductor is, so in a conductor when straight when battery is connected. So when battery is connected, there is a current flow, and when there is current, electrons move in a direction, in a particular direction. Okay, so they flow in a straight path. So this is correct. Then the second one, zigzag when battery is not connected. When battery is not connected, there is no electric current. So electrons can move in any direction or in a zigzag direction. Okay. So this is also correct. Random when battery is not connected. So it is random. We don't know which direction. So it is also the same. So all are correct. So all of these is the correct option. Now electric current. What is the definition? It is the definition only. So amount of charge which passes per unit time through a cross section of the wire. Okay, so that is called the electric current. So first one is what? Amount of charge passed through. Here time is not mentioned, so we need time also to calculate electric current. So this is not correct. And second one, amount of charge per unit time. So it is the amount of charge passing per unit time. So this is the correct option. Okay. So per unit time, and what is your unit time? It is second. So amount of charge passing per unit time through a cross section. This is the correct option. Okay, now the next one. Classify the given materials into conductors and insulators. You are given a picture here, a diagram here. Okay, two diagrams here. This is a circuit, both are electric circuit. Now current is flowing here, from here the positive pole of the battery, and passing through it and going up to the bulb and then coming here. So the circuit is complete and the bulb is glowing. Okay, so now here in the second one, current is going, but it is not reaching up to the bulb because the circuit from here to here is complete. So this B is not a conductor. That's why the current is not flowing up to the bulb. Okay, so we can conclude that both A and B are conductors. So both cannot be conductors. If both are conductors, it should glow. This bulb should also glow. Now A is a conductor and B is an insulator. So A is a conductor because the bulb is glowing, and this is an insulator because the current is not flowing through it. So this is the correct option. Okay, so A is conductor and B is an insulator. Insulator means this is a bad conductor. This is not a good conductor. Okay, so that was the correct option. Now, next one, calculate the current flowing through the wire if 30 electrons are passing through its cross section in 1 second. So, according to the definition, current is the charge flowing through the cross section. We have seen the definition right now here. Okay, here in the seventh question. So the current means the charge, electric charge flowing through a cross section per unit time. So time is 1 second, unit time, you know, and charge is how much? So electron has a certain amount fixed charge. Okay, you will come to know it later, or you can find it yourself. But it has a fixed charge. So now 30 electrons are there. So this is the charge of an electron here. We have written E for it. Okay, use the symbol. Suppose it is E negative, because electron has a negative charge. So 30 electrons will have 30 multiplied by E. So total charge is 30 E, and divide by the time taken. So time is 1 second. So you will get the current here. So okay, so this is the formula. This is the charge divided by time, and you can get the current. So this one is the correct answer, and this is not. Okay, so charge upon time. Okay, this A is the correct option. Okay, now the next one. In a series combination, okay, you have seen in the chapter there are two types of combination. One is parallel and one is series. Okay, so two types of connection combinations are there of the cell. So in a parallel combination, positive is connected to positive and negative is connected to negative. But in series, negative is connected to positive of the other terminal, okay, of the another cell. So this is called series. When positive is connected to negative, again positive is connected to negative. So this is called the series combination. So B is the correct option here. Okay. So this is your question, first exercise. Pick the correct. Okay. You have done all 10 parts here. Do it in your notebooks also. Okay. Just write the correct option in your notebooks. Don't write all the options. Okay. Just write the correct options. Okay. Now you try to find these other exercises. Okay. The fill-ups here. Okay.